If we look at the cylinder, y squared plus z squared equals 1, and we intersect this with the plane x minus y plus z equals 0, then the shape we get is an ellipse like this. So let's say we want to find the points on this ellipse which are farthest from and closest to the origin. Okay, so what we're trying to do is we're trying to optimize f of x, y, z equals x squared plus y squared plus z squared. This is the distance to the origin. And then our constraints, so our subject to G1 of x, y, z is x minus y plus z equals 0. So this is the plane. And G2 of x, y, z is equal to y squared plus z squared minus 1 is equal to 0. Okay, so to solve this with Lagrange multipliers, we'll first write down the gradients of all of these functions. So nabla f is 2xi plus 2yj plus 2zk. Nabla g1 is I minus j plus k, and nabla g2 is 2yj plus 2zk. And so our equation is nabla f is lambda nabla g1 plus mu nabla g2. Okay, now since we've got 2xi on the left-hand side, but there's no I in nabla g2, that has to all be coming from nabla g1. So we get that lambda is equal to 2x. So then if we subtract that from both sides of the equation, we'll get 2yj plus 2zk is equal to negative 2x plus 2yj plus 2x plus 2z. Okay. So now we have the equations 2y is equal to negative 2x plus 2y, and 2z is equal to 2x plus, these should have mu's in front, plus 2 mu y and 2 mu z. Okay, so 2y equals negative 2x plus 2 mu y. If we rearrange that, we'll get mu is, we divide, mu is 1 plus x over y, and 2z equals 2x plus 2 mu z implies mu is equal to 1 minus x over z. So this will give, well, now that these two have to be equal to each other, so either x is equal to 0 or y is equal to negative z. Okay, so let's examine these two cases. So if x is equal to 0, then x minus y plus z equals 0 implies that y is equal to z. And since y squared plus z squared equals 1, actually, maybe I should say, so in both of these cases, so y equals z and y equals negative z, since we've got y squared plus z squared is equal to 1, in both cases we'll have y is plus minus 1 over root 2. And then z will either be the same in the first case or the negative. So by negative plus, I mean whichever sign you took here, take the opposite one here. So the negative plus will be here. Okay, so in both cases, yeah, the y and z's are going to be plus minus 1 over root 2. In the first case, we'll have x is equal to 0. In the other case, we'll have x is equal to 2y from x minus y plus z equals 0. So this would become, we get y minus z on the other side, but then that's 2y. Okay, so we can now finish up. So our points are when x is 0, we'll have 0, comma 1 over root 2, 1 over root 2, and negative 1 over root 2, negative 1 over root 2. And then in the other case, we'll have 1 over root 2, negative 1 over root 2, negative 1 over root 2, 1 over root 2, and then twice, x is twice x, so twice, so this will be root 2 and negative root 2. So these are those 4 points. So these two are closest to the origin, and their distance from the origin is 1, whereas these two bottom ones are the farthest from the origin. Here the distance is 1 plus is root 3.